All right, so we have this quadratic. We need to factor. How does this factor? Alex, Subin, how does this factor? Yep, -4, +5. So our x values, we get x equals 4, we get x equals -5. Please remember to go back and check these answers, okay? If we have an argument that ends up becoming negative, that's a problem, and we don't want to include that as part of our solution. So if we plug in 4, we would have 16 plus 4 is 20, so that works. If we do a -5, we do 25 minus 5 gives us 20. We're getting nice, pretty even numbers, so both of these are solutions, okay? All right, let's look at another example here, though. All right, here we've got a little bit of simplifying or condensing that we have to do first. Colby, how can we condense this? So just focus on this left-hand side.
They can do log x, right? Plus, so it's multiplied.
So it's multiplied. So x times x minus 3. Yep. So if you want to do this in 2 steps, you can. If you're okay with doing this right away and realizing, okay, this is x squared minus 3x, that's fine also. So we have log of that amount equals log of 28. And so once again, we're saying log of something equals log of something. And so we can set those somethings equal to each other. So x squared minus 3x equals 28. It's quadratic again. Sophia, can you help me with factoring this one?
I'm not sure. I forgot how to do it.
Okay, we're looking for numbers and multiply to give us the 28, that add or subtract to give us that -3.
Oh, 7 and 4.
Okay, there you go. So -7, +4. So that gives us then that x is equal to 7, x is equal to -4. We need to go back and check. If I plug in 7 in for this x, I'm going to get 7, that's okay, and a 4, that's okay. But if I plug in this -4 here, then I'm going to have a negative argument, and that's a problem. So what that's telling me is that this is not a solution, but that this is. Okay. Questions? And then there's one tiny little trick with number 6 here, if you notice, and that is we've got these logs on 2 sides here, but we've also got this other number that's getting added to it. So that kind of complicates things a little bit more. We actually want to get the logs together on the same side so that then we can condense this. So first step is to get this all together on one side and say that that's equal to 1, and then we need to go from there. Okay? All right, so how do we condense this then? John, help me out with that, please. So the left-hand side, so I'm seeing subtraction.
So you divide it?
So we're going to write it as a division problem. There you go. So we're going to have log of, what's going to go on top?
3x minus 4.
Yeah, oops, sorry, let me switch to pen. So 3x minus 4 all over 2x plus 3. Good. And then that's equal to 1. You good with that now? You okay? Because you were like, I'm not so sure. But yeah, that we had subtraction, so we rewrite using division. Now, guys, this is kind of precursor of what we are about to start to look at. And you've done this a little bit already, but I've not stressed it as much as I'm about to. Here's the deal. I need you to think about the fact that we have logarithmic equations that we're going to be solving, and we have exponential equations that we are going to be solving. When we solve equations of any type, you've got to be thinking inverse operation, right? Think inverses. So when you see something that's logarithmic, the inverse of logarithmic is exponential. So in order to solve this logarithmic equation, we're going to rewrite this using exponents. So think about your E, if you're the type who draws the E, draw your E. Otherwise, remember your first, last, middle to help you rewrite this using exponents. Okay? All right, so if we rewrite using exponents, what's our base understood to be, guys? 10, yes. So we have, all right, Ireland. Okay, we have 10 to the first is equal to 3x minus 4 all over 2x plus 3. All right? Okay, so we had logarithmic. We've just rewritten this as exponential. And now from here, we need to try to solve. This looks like it's just another proportion. So we're going to cross multiply and solve here. So when we cross multiply here, we're going to get 20x plus 30 equals 3x minus 4. Let's subtract the 3x. Let's subtract the 30. So x is -2. All right. We need to go back and check to see if this is going to work. So if we plug -2 up here in here for x, we're going to have 3 times -2, so -6 minus 4 is -10. That's giving us a negative argument, so this is no solution. I'm going to abbreviate that, just no SOLN. So all of that work, and we found that there's no solution. It happens. Okay? If you need to put a reminder here, no negative arguments. That might be a good reminder. Okay? Okay, so if we can rewrite so that we have logarithm equals logarithm, then we can focus on just that other stuff, right? That's what we did for numbers 3, 4, and 5. Number 6 is kind of precursor of what we're about to look at, right? So I want you to think about this, and I want you to a huge note on this page. If you notice, all of these are logarithmic equations. And I'll talk to you about these directions here in just a second, but all of these are different logarithmic equations. If you cannot do that fancy special case of log of something equals log of something, so we can focus on that, then you are going to have to do this, and that is you are going to rewrite using exponents. So put a huge somewhere on this page. Anytime you see an equation, the first thing to ask yourself is, what type of equation is it? If it's logarithmic, if you are going from logarithmic equation, if you have a logarithmic equation, then in order to solve, we are going to have to rewrite using exponents. That is our inverse operation. Okay? What we're going to look at on the next page, those are exponential equations. Think inverse, it means we're going to have to think logarithms. So we'll get to that, but on these we are rewriting using exponents. There might be some cleaning up we have to do first, but that's what you have to keep in mind is these are logarithmic equations, rewrite using exponents. I'm almost tempted just because the thing I think that can be hard, like you get into the habit of doing this particular thing. Okay, we're going to rewrite all of these using exponents. But on a quiz or a test, if you see a logarithmic equation and then you see an exponential equation, you got to kind of be able to switch your thinking. So I'm almost tempted to I'm not going to do it, but I'm almost tempted to bounce back and forth from page to page just so that you're having to think about, okay, what type of equation is it? That's the first question you need to ask yourself. What type of equation? What's the inverse? Because that's what I'm going to have to do. Okay, so keep that in mind, please. All right. Let's look at some examples of this type. And I want you to notice the directions. A lot's gonna depend on whether or not these equations are put on the basic calculator portion of the test or the with graphing calculator portion of the test, okay? So if it's with the calculator, you're gonna be rounding to some place because you're literally just gonna plug this into your calculator. If it's on the basic calculator part, you're gonna kind of leave answers in a format, so you'll kind of see that, okay? All right, let's look at some examples here. Logarithmic equation. I'm seeing numbers out front though that we need to kind of deal with before we can rewrite using exponents. So I'm gonna divide both sides here by 2. And then I get Lx is equal to 9. So we want to get that logarithm by itself, and then we are going to rewrite using exponents. Okay. What does ln of x really mean? What's the base understood to be? Careful. ln. Yes, good. There you go. So log base e of x equals 9. Now we want to rewrite this using exponents. Like I've said before, if you draw the e, if you're a visual person and you draw the e to write the exponent, do that. If you're the first, last, middle type, that works too. So first, last, middle tells us we have e to the 9th is equal to x. That's our answer. That's our exact answer. So if this question were on the basic calculator part, you're done. Right? If you're on the graphing calculator section, then you're going to your calculator and you're plugging in e to the n and you're finding out what the decimal it is that it's equal to. So in this case, x is about 8103.08. Okay. All right. Comments, questions? What do you think? You're speechless. Okay, someone help me out here. Vivian, what should we do first on number 8?
Divide by 7 minus 3. Would you divide by it?
Okay, we do want to divide, but that 7 is getting added. So we don't want to divide by 7, we want to subtract that 7. Right? Do you see that? Okay, so we want to subtract that 7, so that gives us -3. That's what we're going to divide by, right? Okay, so then we have log of 10x equals 6. Okay, now we can divide by that -3. You were definitely wanting to clean things up, and that's good. So log of 10x is equal to -2. All right, we're kind of at a stopping point because it's like, okay, now what? And that's when you need to be thinking, this is logarithmic equation, so I need to rewrite using exponents. So Vivian, how do I rewrite that using exponents?
10 to the -2
Yep,
is equal to 10x.
is equal to 10x. Beautiful. Okay, 10 to the -2, that is equivalent to 1/100 equals 10x. So in order to solve here, we're going to multiply by 1/10. So we're going to get that x is 1/1000. Okay. We're going to skip that next one. That one's a little bit more straightforward. Let's look at 10, and we'll look at some down here. Yeah. How about 10 and 11 and 13? 11's kind of tricky just because of the fraction, so we'll take a look at that. Okay, all right, number 10. Alex Leary, we have a logarithmic equation. So what are we gonna do?
3 to the 4th
Yep, 3 to the 4th
equals 2x minus 2.
equals 2x minus 2. Beautiful. Okay, and 3 to the 4th is 81. 2x minus 2, let's add. We can write it as 83 over 2 if you want to. If you want to put it as decimal, you can also. Okay. That one wasn't too bad, was it? Okay. All right, we have logarithmic equation. We are going to rewrite using exponents. So CJ, what do we get here?
A to the negative 1 equals 7 minus 2x.
Great. 8 to the negative 1 is 7 minus 2x. This one's a little bit tricky just because we're going to deal with this fraction with this 1/8. Okay, so we need to subtract this 7. So that gives us, I want to rewrite that 7 as with common denominator of something over 8, right? 8 times 7 is, so this is really a minus 56 over 8. So if we do 1 over 8 minus 56 over 8, we get negative 55 over 8 equals negative 2x. Okay? Think about that for a second. I just found common denominator. I'm rewriting this negative 7 so that I have my common denominator there. Are we good with that? I hope. Okay. You guys aren't really saying anything, so I'm not quite sure how to interpret that. All right. We're trying to solve for x here, so we've got to multiply. I would multiply by negative 1/2. I would think of it as multiplying by negative 1/2 rather than dividing by 2, just because of the fraction there. I think it's easier to think of it that way. So x is equal to, CJ, what's that going to give me?
Do you cut the portion in half, or does it go bigger?
It's fraction, so we're just multiplying. So negative times negative.
Negative, or positive 55 over 16.
There you go, 55 over 16. And if you want to convert it to decimal, that's about 3.4375. Beautiful. Okay, let's look at 13. Yeah. And that one, if you notice, we've got some condensing we need to do before we can rewrite using exponents. Logarithmic equation, we're going to rewrite using exponents, but we got to clean things up first. Kylie, how do we clean that up? What are we going to have? We're going to have log base 9 of what?
X squared over 3.
There you go. Good. X squared over 3. And then that's equal to 2. Awesome. Take a look at that. Make sure you follow. Are you okay with how we got the x squared over 3? Okay. All right. From here, Kylie, what are we going to do?
9 squared equals x squared over 3.
Okay.
So that's 81 equals x squared over 3.
X squared over 3. Keep going.
And then you multiply both sides by 3.
Okay. So we get 243 equals x squared.
And square root.
So we need to square root that, and we get that it's about 15.59. Now, technically, because we are taking the square root of both sides, we should be considering the positive and the negative. But is the negative going to work in this case? Think about the argument there. If we were to plug in a negative 15.59, that would be a problem. So that would not be part of the solution, but this would be. Okay? All right, so those are logarithmic equations that weren't kind of that special case of log of something equals log of something, set them equal to each other. So on all of these, if it's a logarithmic equation, we rewrite using exponents. That's the inverse operation, right? Okay, now we're going to look at exponential equations. Let's go ahead and put the note in there. It means we are going to have to take the log, or the ln, it could be either one, of both sides. Right? But first, so make a note about that down below, but let's look at these two. If you notice, it says, what's the difference between how we solve those two problems? What do you notice that changes how we would solve each of these?
Common numbers with 3 and 1.
Okay, no common numbers here. No common base, maybe, is a good way of writing it. But here we can rewrite in terms of the common base. So that's what you want to look for. So once again, you're always looking for, is it that special condition of, something in common, basically? If so, we know how to solve those already. We've been doing that. But if not, we've got to come up with a way of solving this, right? It's exponential. It's an exponential equation. So in order to solve, we do the inverse operation. That means we are either going to take the log or the ln of both sides. When would we do ln? Why would we use ln and not log? Yeah, if you see an e as part of the problem, then we're going to do ln. Otherwise, we're going to use log. Okay, so let's look at kind of some simpler basic ones, and then we'll look at a few that are a little bit more complicated here. So let's go pretty simple and basic here. It sounds corny the way I'm going to say this, but I think it helps some people understand. We have an exponential equation, so we need to consider the logarithms. So we've got to take the log of both sides. Guys, it's really important that you remember to take the log of both sides, that you remember to put that log on the right-hand side. Okay, so here's what part of the issue is. We're trying to solve for x, and x is in the exponent, right? And we don't know how to solve for x if it's in the exponent. But our properties, now that we're taking the log of both sides, we have that beautiful property that tells us we can drop that x out in front and we can multiply. It's that power property. It means that our exponent is dropping from being an exponent land to, this is, like I said, this is the corny part. We're dropping our x from exponent land into just regular numerator. So this becomes x times log of 3 equals log of 7. So now taking the log of both sides has allowed us to get that x in the numerator where we need it. And now we can solve. So to get x by itself, we're going to have to divide by the log of 3 on both sides. Okay? All right, a few things we've got to talk about here as well. If we're on the part of the test where you don't have your graphing calculator, then this is where you would stop. This is referred to as the exact answer. If you've got your graphing calculator, then you're plugging that into your calculator and you're going to get an answer here. And in this case, it's 1.77. Okay? Guys, do me a favor and grab your graphing calculators, because there's something really important I need you to understand. Yes, on the very back, I've got one of mine that's charging. Here's the other mistake that a lot of people make when we're dealing with logarithms. I need you to notice that there is a difference. These do not mean the same thing. We get different values. So plug into your calculator log 7 divided by log 3. And on that, you should get about 1.77. Did you get that? Yes? Okay. All right, now try plugging in just log of 7 divided by 3. And I want you to see you get a very different answer. What do we get for that? 0.37? Is that what we got? Okay. Okay. Very different answers. It's really important that you keep track of where these logs are, right? What we're taking the log of and if we're condensing and we're writing it as a single log. So please, please, please be careful of that. These do not equal the same thing. They do not mean the same thing. So you do have to be conscious of that. It's very easy to forget, like you write this log here and then you forget to write it here when you are actually doing the solving. So that's another place that people tend to make mistakes. So I'm kind of trying to highlight or point out some of the mistakes people tend to make with these, just so you try to avoid them. All right, let's look at another example here. All right, Zach, we've got exponential equation. So in order to solve, we are gonna take the log of both sides. So help me from here, what am I gonna do?
X parentheses log 2 equals log 172.
Okay, so 3x times log of 2 is equal to log of 172. Beautiful. Okay, now we're trying to get x by itself, so what do you want to do next?
Do we have to divide the log 2 or divide the 3?
Yes,
Well, both.
both.
But,
so
doesn't
it's
matter what
personal
order.
preference. It does not matter the order. You can divide them all at the same time, or you can divide them separately. So that's why I said yes to this, right? So one option is to divide by the log 2 first and get that answer. And then, oh yeah, by the way, once we have that answer, now let's divide by 3, right? So that's one way you could write this. The other way is, if you notice that right away, you can just truly plug into your calculator. I'm trying to talk and write at the same time, and it's not going well. You should get the same thing if you plug in as log of 17 divided by 3 times that log of 2.
172.
Oops, 172. Thank you, sorry about that. Yep, good. Okay, so once again, exact answer, if this is on the no calculator part, you would write one of these, either one of these. If you are plugging into the calculator, if this is on the graphing calculator section, then you're plugging into the calculator and you should get that this is about 2.48. Okay, all right, we are going to look at number 4 and number 7, and then we are done. And then I will explain about your homework. It's a textbook assignment. Okay. Talia, can you help me out with this one? This is number 4. What
Do
should-
you like change it to the LN?
We are gonna take ln, you're right, but we've got some stuff going on here, like this 7 out front that we wanna deal with first, and this. So if there's extra stuff going on with the exponents, we gotta deal with that first, right? And then you're right, we will go ln. So what do we need to do with first there?
Subtract the 2.5.
Yep, okay, so let's subtract the 2.5. So that gives us 17.5, and then what?
Divide by 7.
Okay. All right, so we have e to the 2x is equal to, what is that equal to? I'm looking, 2.5. Okay. Now, like, this is truly, I'm not kidding. Like, when I solve problems, I kind of get to this point and I kind of feel like, okay, I'm stuck, I'm stumped. Where do I go from here? And it's gonna happen to you guys too. So the first question you ask yourself is, what type of equation do you have? And this is an exponential equation. Exponential equations means in order to solve, we're doing that. We're either gonna take the log or the ln. Okay, so keep that in mind, because I can promise you it's gonna happen. When you're doing your homework or you're taking the test, you're gonna kind of get to this point and you're like, you get stuck. You're like, I don't know what to do from here. So that's where you have to remember, okay, it's exponential. I'm gonna take the log or the ln of both sides. Like Talia said, in this case, because of the e, we're taking the ln, right? So ln here, Okay, now what, Talia?
You move the 2x.
Okay, so we get 2x times the ln of e equals the ln of 2.5. So important to remember this ln here. Guys, what's ln of e equal to? Say that really loud with conviction. 1, yes. Remember, ln of e is equal to 1. So that's the convenience, that's the beauty of this, is that ln of e just becomes this, that's 1. So it's like it disappears because we're multiplying by 1, right? So now we need to solve for x, so we're gonna have to divide by that 2. So our final answer, our final exact answer would be ln of 2.5 all over 2. If we are going to take that one step farther and actually get the decimal, that's about 0.46. Okay, this is another really important point to remember. ln of e is just equal to 1. Okay, hang in there, we're almost done. I know this has been long. Let's look at this one. Okay, Leah, can you help me with this one?
Sure. You subtract 7.2,
Okay, let's subtract that 7.2. Good.
and then you rewrite the first part as, do you put 2x over 5 in front,
Yep, because we're going to take the ln,
and then do ln?
and because so now, yeah, that property tells us we drop that out in front. Beautiful. So 2x over 5 out in front, and then what?
And then equal to 1.9.
Okay, here, careful, hold on. We need this part still also, right?
Equal to ln of
Okay, so 2x over 5 times that ln of e, which, I mean, the nice thing is that, okay, that kind of disappears, so we don't really have to worry about that anymore. And then on the right-hand side, remember, okay, that's going to be equal to, don't forget that ln, guys, of 1.9. Okay, now we're trying to get x, so what do we have to do to get rid of that 2/5, Leah?
do you multiply by 5 over 2?
There you go. We want to multiply both sides by the reciprocal, so we're going to multiply by 5 over 2. So 5 over 2 here. So x is equal to, so 5 times the ln of 1.9 all over 2. That's exact answer. If we're looking for the decimal approximation, we get that if you plug in. Okay?